Well, hi guys, this is Mr. A. This is the last video I'll have for you for factoring, and this one's for factoring completely. So we're going to take everything we've learned so far in the previous videos, we're going to combine it all together and get one general strategy for how to factor an expression completely, okay? So there's not a lot of, there's not really any new stuff in here. We're just going to summarize what we've done and then do maybe a couple of examples, and the rest of it's going to be on you, okay? So I just want you to look at this screen right now while I explain what's going on. And we always start factoring problems by checking a GCF first. I've kind of emphasized that a couple of times in some of the previous videos. So make sure you always do that, because that can help reduce possibilities for factor pairs if you're factoring a trinomial, and also might also help find the groupings GCFs for a grouping as well. So always check for a GCF first. You've got nothing to lose. But in fact, it makes the problem a lot easier if you factor out a GCF first. So just get in that habit. Next, count your terms, because depending on how many terms you have depends on what method you want to use. Okay? So if you have two terms, if you know the factoring pattern is a difference of two squares, you can factor it that way. Otherwise, you're going to want to try the ABC method. The ABC method works for all two terms and all three term polynomials that we're going to have. Okay, if it's factorable, you can use that method to factor it. So those are two options for two terms. Two options for three terms. You could, if you want to guess and check, you can. You have to still show your work though if you guess and check, but you have to show your factoring process. But you can still guess and check. You can also use ABC method on that. And then lastly, four terms is only one option. We can only factor four terms by grouping. Okay, so the first thing we do is we check for GCF, and then it's the technique we use is dependent upon how many terms we have. Okay, so let's go ahead and take a look at an example or two. I don't know how many we're going to do yet, but we'll just kind of take a look here and see. And then we'll take a look at any last things we might need to in order to get done with this topic. Okay, so I'm going to go ahead and look at this first. Let's do this first one here together. So first thing we're going to do is find a GCF. So let's just write that over here. GCF. Looking at the numbers, I see that we can pull out a 2 from each one of those, and there isn't any GCF with the variable, so the GCF is 2. So if I divide these by 2, like so, I'm going to write the 2 on the outside. And if you remember a couple of videos ago, I did do a problem that had a GCF in it. And how I did that was I used square brackets to enclose the expression that still might need to be factored. So I still have 3x squared minus x minus 10. Okay, so that way when I use parentheses in my groups, it doesn't conflict with the brackets. Okay, now we're going to factor the trinomial. And I'm not going to do the guess and check method. I'm going to use ABC method. So we're going to have A is 3, B is -1. Let's write that a little bit clearer. C is -10. So we want a factor pair of A times C, which is -30. And it has to add up to -1. So if I do a little bit of checking here, I would find out that the factor pair that I need is -6 and +5. They add the -1, multiply -30. Okay? So I'm going to do the same work. I'm going to split up the middle term here. So I'm going to write it in black again. So and here's the thing. Whenever you have a GCF, you have to keep it in your work. Okay? It has all the factors in your final answer must multiply together to the original expression. So make sure you keep this 2, that's our GCF, in your steps. Don't lose it, because if your final answer does not multiply back to the original expression, you'll lose some points on your assessment for that. Okay? So keep that in mind. So we're going to go ahead now and do 3x squared, split with the middle term, minus 6x plus 5x minus 10. Okay? And then, oops, I picked yellow by mistake. Let's do purple again. Keep it consistent. So there's our grouping. Okay. Bring down your 2. And we'll pull out GCFs. And we'll do that with red and blue again. So the GCF of the first group is 3x And left over is x minus 2 from the first group. Check your signs. I think our signs are good. Okay, we got a positive and a negative term, and we have a positive negative term in the blue group. So we're just going to pull out our positive 5. Left over is x minus 2. And so that's our factoring here. And I believe our groups match, which is great. So now I can finish it up. I can remove the square brackets now too, okay, because I have everything ready to go for my final answer. So I'm going to bring down the 2 one more time. So it's going to be 2 times 3x plus 5 times x minus 2. Okay? That's the final answer. And that's how we factor an expression completely. We have to just incorporate all of our techniques to make it happen. So that's our first example. I'm going to look around here for a minute and see what other examples we have. This one I'm going to leave for you to do. We're going to look at this one here in just a second. That's a good one to look at, actually. We'll take a look at it. 4 is also a good one to look at. 5 is also a good one to look at. I'll give you guys a couple of pointers on some of these, and then you guys can finish them up. Some of these are going to require 2 or 3 methods in order to solve. Okay, so I'm gonna get you started on some of these, but then the rest of them is going to be up to you. 2 you're going to do on your own. So you have that example. I'll work this one here with you. This is going to be really kind of cool. So if you notice, we have fourth powers here. That's going to present an interesting situation. So let's start out again, figure out there's a GCF here, and of course there is. Hopefully you guys figured out that it's 5. Okay, so we're going to divide by 5. Okay, so I get x to the 4th minus 25 y to the 4th when I divide by 5. Don't forget your GCF on the outside. And I just realized I need square brackets for that, because we are not done. Okay, because inside here is a difference of 2 squares. Okay, because x to the 4th is perfect square and 25y to the 4th is perfect square. So let's do our ABC method on this. So a equals 1, b equals 0, and c equals negative 25. Okay, so if I want to factor a pair of negative 25, because 1 times negative 25 is negative 25. The factor pair that I want is 5 and negative 5. I'm going to move this over just a little bit so it lines up there and I have more room to work. Okay, so bring down your 5. Keep the square brackets. Split up the middle term. Oops, you need red. There we go. X to the... There we go. X to the 4th. Now here's the thing with this, okay? These are 4th powers on the ends here. So when I write the middle term here, I want it to become 5x squared y squared. Okay? Because I want my final factorization to multiply back to this original statement here. And when I multiply x's and y's together, that becomes xy. And I know that I'm going to need the square root of x to the 4th, which is x squared, and the square root of y to the 4th, which is y squared. So it's going to become, those middle terms are going to become x squared, y squared terms. Okay? So this is where it gets a little tricky, but it's still manageable. Move this over one more time, so I have a little bit more room here. Okay? And then you're going to have minus 25 y squared. Okay, we're going to group them together. So group and group, like that. And we're going to bring down the 5 and the bracket. Pull out an x squared, because that's the GCF of that group. And left over is x squared plus 5y squared. And in the second group, we're going to pull out a negative 5 y squared, okay, because I need the signs to be the same in my groups. It's going to become x squared plus 5y squared. Okay, my groups match. So I can write my factorization as it is right now, which is 5 times x squared minus 5y squared times x squared plus 5y squared. And as it turns out, that's as far as this one goes. So we are finished with this problem. But I still have to check sometimes, because sometimes these factors that I have left over in this step, they might factor themselves. So I need to make sure that everything is as factored as possible before I box my final answer. So be on the lookout for that, because you might encounter a grouping here, hint, hint, that might have to be factored some more. Okay? Like in one of these other problems that come up here somewhere along the way. Okay? Just saying that one of these in 4 or 5 or 6 is probably going to present you with that situation. All right? So there you have it. And maybe more than one of them. So keep that in mind. I'm going to let you do 4 now. I think you can handle that one. Just watch your exponents on your x when you do number 4. Let's look at number 5 here for a second. We haven't done one with a negative coefficient for the leading coefficient. So let's take a look at it for a minute. I'm going to get started on this, okay? The only thing here you can do a couple of things. The GCF could be -1. If you wanted to factor out -1, you could do that and make the first term positive. More than welcome to do that. Or you could just work with it. Either way you go about it is perfectly fine. So if you go with it as it's written, you would have A equals -1, B equals 3, and C equals 10. Okay? And so then your A times C value would be -10, which means that your factor pair you would want is 5 and -2. Okay? So let me write that again so it doesn't, there we go, 5 and -2. So you're going to work it the same way. You're just going to keep everything, you're going to keep your signs aligned so that when you do your grouping step that your groups are still going to match. Okay, so don't let that negative sign in front of the x squared term throw you off. It works exactly the same way. Split it up. So you're going to have -x squared plus 5x minus 2x plus 10. I'm going to let you finish it from there. Okay, so you can factor by grouping from there and get a factorization. All right? So don't let that negative sign throw you off there on that. Take a look at the last one here. You guys should know what to do by now. You're going to group them together, like so. Now, when you do this, though, group that, there you go, group that sign there, that -18y. In fact, I probably should just move that over here just a little bit here. If it will let me. There it goes. Just so we have enough room to do this correctly. There we go. So move that over so you have plenty of room. And then you can try factoring them by grouping. Now, be careful here, because I got a feeling on this one you're going to have to factor twice. Okay, I have a feeling that there's going to be something there somewhere that's going to be able to factor again. So be mindful of that. It might not happen. Okay, I haven't looked at the answer key yet on this one for a while. So it might not happen, but it could happen. So be mindful of that and just try it. Okay, and that's basically how we factor expressions in algebra. Before we go, just a couple of things. I'm sure you probably are asking yourself as you do this. Why do I have to know how to do this method? Well, Algebra 2 and Geometry both require you to know how to factor some things in order to do geometry-related problems with expressions like this. In Algebra 2, will require you to do this as a step in a larger problem. In Algebra 2, you're going to have to encounter things like algebraic fractions, where the expressions on the numerator and the denominator are both these kinds of expressions, and you have to simplify them. You'll have to add them. You'll have to subtract them, have to multiply them together. And so in order to do those kinds of things, it's best to factor things first, because then really cool things happen when you have these expressions in factored form. So a lot of the time it will make your problem a lot easier for an expression to be in factored form than in standard form. So in a nutshell, that's why we need to know how to do this method, because it's going to encompass a lot of your Algebra 2 work and also some of your geometry work when you go to take those classes the next 2 years. All right. So again, if you have any questions on any of these problems or you want some more in-depth explanations, just let me know. Drop me an email, and I hope your work for the next 2 weeks goes well. Remember that in order to take the assessment over this topic, you have to have at bare minimum the review assignment and the knowledge web for this topic completed, and submit it before I grant you permission to do the assessment. So if you could make sure those things are done at the minimum, that'd be great. I am accepting all the other assignments for grades, okay, and those will be counted against you if you don't have those in. But at bare minimum, in order to do the assessment, you have to have the review assignment completed and the knowledge web. And then everything's due by Thursday the 26th. So if you could get those things taken care of, that would be great. Hope to see you guys soon. Take care.